Hello all, welcome to the course on Python programming for beginners. In this session, we are going to discuss about Pandas lecture 1 of module 20, which includes the topics overview of Pandas, installing and importing Pandas, creating Pandas objects, and viewing data from Pandas data frames. First, let us see the overview of Pandas. Pandas was built on top of NumPy. Pandas was specifically designed to work on tabular data. The name Pandas was derived from the two words panel and data, which means the tabular data. There are three fundamental Pandas data structures which include series, object, data frame object, and index object. Pandas provides useful tools, methods, and functionality for data analysis. Pandas supports a variety of functions including reading and writing from tabular data, and we can create plots using Pandas. We can select a subset of a table. We can derive new columns from the existing columns, and also we can calculate summary statistics including minimum, maximum, median, counts, etc., which gives the descriptive statistics of the data. Using Pandas, we can also reshape the layout of the tables. We can also combine data from multiple tables. Now let us see how to install and import Pandas. Once you have Python and pip installed in your computer, you can open your terminal or command prompt and run the pip install pandas command to install Pandas. This will download and install the latest version of Pandas and its dependencies. Once you have the Pandas installed on your computer, you can import in your program by using the import command. Import Pandas as PD. So in the later part of your code, you can use PD instead of Pandas, and here PD is serving as the short form for Pandas. You can also know the details of installations on various other platforms by going into the link pandas.pydata.org. Now let us see the two important Pandas objects, which include series and data frame. In Pandas, a series is a one-dimensional labeled array capable of holding data of any data type. And data frame is a two-dimensional tabular data structure with labeled axis, which includes the labels of rows and as well as columns. It is similar to a spreadsheet or an SQL table. So you can consider series as a one-dimensional array and data frame as a two-dimensional array, both of which are having indexing as well as column labels. Now let us see how to create Pandas series object. And in Pandas, a series object consists of two components. One is data and the other one is index. So we can create a series object by passing a list of values with or without an index. If we pass the index value will be retained in the series object. And if we don't pass any integer index, then in such a case, Pandas creates a default integer index. Now let us see the code for creating a Pandas series object. S1 equal to pd dot series. Here we are passing the data, which includes some 6 different values, and the last value, if you observe, it is np dot nan. Nan stands for not a number, and this nan value is defined in the numpy package. That is why we have to import numpy also in addition to pandas. So when we try to print the value of S1, it is going to print all the values that we have passed to the series object, which includes 1, 2, 3, 4, 5 and np.nan. And you can also see the index, which is the default index, because when we created the series object, we did not pass any index, but Pandas is taking the default integer index, which is ranging from 0. So in addition to the data, if you want to pass the index also, you can do so by using another argument, which is index. So For creating a series object along with the index, you can use the same function pd.series, and the first argument is the data, which is the list of values that you want to insert in the series object, and the second argument is the index. Here we are using np.arange function, which has the starting value, which is 10, and 70 is the last value or stop value, and 10 is the step value. So from 10, 20 up to 60. So it will not include 70. So these three arguments are nothing but start, stop, and step. Start means the starting index, and stop means it will not include 70 but the value before 70, which is 60 in this case, because the step value is 10. So from 10 onwards it will increment by step value. So 10 plus 10 20, 20 plus 10 30, and so on. So this in this fashion we can create a series object by using explicit indexing. So if you don't pass any index, Python is going to take the default indexing, which is ranging from 0 to n-1. Now let us look at Pandas data frames. In Pandas, a data frame is a two-dimensional tabular data structure with labeled axes, and it is a primary data structure used for handling and manipulating structured data in Python. The data frame is similar to a spreadsheet or an SQL table, and it provides a powerful and flexible way to work with data. Now let us see how to create an object using the Pandas data frame. We can use the function pd.dataframe by passing the appropriate data, and here we are passing the dictionary as an argument for pd.dataframe. And we are creating a dictionary by using the key value pairs. Here we are having three different keys: name, age, and city, each of which are having four different values. So for example, Elise, Bob, Charlie, and David are the values of the key name. Similarly, their corresponding ages and the corresponding cities. So with this, we created a dictionary, and this dictionary we can pass as an argument for creating the data frame by using pd.dataframe. And when we try to print this data frame, you can observe the output, which is appearing as a tabular data, which includes all the columns corresponding to each of the key value pairs in the dictionary. In addition to that, we also have an index which is ranging from 0 by default. So this is how you can create a data frame in Pandas. In the previous example, we have seen how to create a data frame by using the dictionary object. And now let us see another example of creating a data frame where we use a date time index other than the integer index ranging from 0. So for creating the date time index, we have to use the Pandas date underscore range function, where you can give the starting date and also the ending date and also the frequency. So here in this example, we have considered the 1st December 2023 as the start date and 8th December 2023 as the ending date, and the frequency is D. D stands for day. So that means once we have the first value as 1st December, the next value will be the next day, which is 2nd December, and so on and so forth. So here frequency indicates the value by which the start value has to be incremented. So in this case, each time the index value is incremented by 1 day. So once we have created the date range, the same date range you can pass as an argument in order to create the data frame. So in this example, we have created the data frame df by using pd.dataframe, and we are passing the index as date underscore range, which is the date range that we have created. And once you have this empty data frame, you can keep on adding any number of columns by using df of the label of each column. Here temperature is one more column we want to create, and humidity is another column that we wanted to create. So you can include any number of columns by using df of followed by the label which is mentioned within the single quotes, and you can create the set of values by using np.random.randint. In this case, we are trying to generate uh, the number of random values which is equal to the length of date underscore range function. Date underscore range, which is nothing but the index value. Here the index value is considered from 1st December to 8th December, so which includes some 8 different values. So length of date underscore range will be 8 in this case. So it is going to generate any random value which lies between 60 and 80. So 8 such values will be generated for temperature. And again, same is the case with humidity also. So df of humidity, that means we are trying to create another column whose label is humidity, and we are generating the same set of 8 values by using size equal to length of date underscore range. And in this case, the humidity values we are putting the criteria as the value should lie between 40 to 60. So once we have created these two columns, we can print the data frame. Now you can see the data frame consisting of the date range index with two other columns that we have just included, which is the temperature and also the humidity values. So in this way, we can create a data frame with date time indexing, and we can insert any number of columns to the data frame having the date time indexing. Now let us see how to view the data from a data frame. There are two important functions, head and tail, that are most commonly used for viewing the data from a data frame. So by default, data frame.head is going to display the topmost 5 rows, and data frame.tail is going to display the bottommost 5 rows. So here you can see df.head, where df is the data frame that we just created, which includes 8 different rows. And if we use the function df.head, it is going to display the topmost 5 rows, and df.tail is going to display the bottommost 5 rows. So 5 is the default value. So other than 5, if you want to mention any other value for displaying those many topmost rows or those many bottommost rows, you can do so by passing the value of n as an argument to head and tail. So in this case, df.head of n is going to display the topmost n number of rows, and df.tail of n is going to display the bottommost n rows. In a Pandas data frame, df.index and df.columns are the attributes that allow us to access the row index and column names respectively. Now let us see how to use them. So if you use df.index, it is going to display the index of the data frame. Here since we have created the date time index, it is displaying all the values of the index. So from 1st December 2023 to 8th December 2023, and here you can see the D type of this index is the datetime object, and here the frequency is equal to D. And similarly, if you want to view what are the different columns in the data frame, you can do so by using df.columns. So the output of this is going to be the list of all the columns in the data frame. Since in our data frame we are having only two columns, temperature and humidity, it is going to display the two columns, temperature and humidity. There is another function which converts the data frame object into a numpy array, which is called as to_numpy. So this function is used to convert a data frame into a numpy array, but this function does not include the index or the column labels of the data frame in the output. That means if you look at the example of the data frame that we have created just now, it is having the date time indexing. So this is the index of each row, and we have two different columns having the labels temperature and humidity. And when we try to convert this data frame into a numpy array, in the resultant numpy array, each column is appearing as one column in the resultant numpy array, and these two labels temperature and humidity are eliminated, and also the indexing is also removed in the resultant array. Now let us see the use of the describe method in Pandas. The describe method in Pandas is used to generate descriptive statistics of a data frame, and it also provides a summary of the central tendency, dispersion, and shape of the distribution of a data set. This method is used for quick data analysis and understanding the basic statistics of numerical columns of the data frame. So this describe function is used to know the summary statistics of the data, which includes only the columns having the numerical values. Since in our data frame, both the two columns, temperature and humidity, are having the numerical data, so it is going to give the summary statistics. Df.describe is going to give the count, means how many rows are there under each column, which is 8 in this case, the mean of all the values of temperature and humidity, the standard deviation, what is the minimum value in temperature and humidity, and what is the maximum value, and what is the first quartile value, second quartile value, and third quartile value. So these are the descriptive statistics that are computed as when we use the function df.describe. Next, let us see how to transpose the data in a data frame. The transpose method in Pandas is used to transpose rows and columns of a data frame, and it swaps the rows and columns, converting the columns into rows and vice versa. And this transpose is explicitly useful for reshaping our data or obtaining a different view of the data frame. So for applying transpose on the data frame, we can use df.t. Here you can see the columns temperature and humidity are appearing as rows, and the index is appearing as the different column labels. So here you can see the column labels as 1st December 2023 to 8th December 2023. So it gives a different view of the data frame. Next, let us see how to sort a data frame. The sort underscore index method in Pandas is used to sort a data frame by its index. By default, it sorts the data frame along the rows based on the index values, and this method returns a new data frame with the rows reordered. We can also sort in descending order by passing ascending equal to false as the parameter. The default value of ascending is true, in which case the index will be sorted from low to high. That means from 1st December to 8th December, this is the default ordering. Since our original data frame is also in the ascending order, it is not going to change. So the output will be the same. When we change the value of ascending equal to false, in that case, the index value is going to be reordered, and correspondingly the rows will be rearranged in the resultant data frame. So when we see ascending equal to false, the index is rearranged from 8th December to 1st December. That means in the decreasing order. In the previous example, we have seen how to sort a data frame based on the index. We can also sort a data frame based on the values of any particular column, and for that we have to use the function sort underscore values. So df.sort underscore values If we want to sort the data frame based on the values of the temperature, then we have to pass the value temperature as an argument by equal to temperature. So in the resultant data frame, the data frame will be sorted in the increasing order of the values of the temperature. Similarly, if we give by equal to humidity, in such a case, the data frame will be rearranged based on the increasing values of humidity. With this, we came to the end of the session, and before closing the session, let us quickly summarize the content that is being covered in this session. We have seen how to install Pandas by using a pip install Pandas. We have seen how to import Pandas package in our program by using import Pandas as PD. And we also have seen how to create a series object by using pd.series, and also creation of a data frame object by using pd.dataframe. And we have seen few more functions of the data frames, including df.head that displays the topmost 5 rows, df.tail that displays the bottommost 5 rows, and we have seen the three attributes: df.index, which displays the index of the data frame, df.columns, which displays all the columns of the data frame, and df.t, which is the short form attribute of the function transpose, which transposes the given data frame. We also have seen the functions df.to_numpy, which converts the data frame into a numpy array, df.transpose, which is equivalent to df.t, which transposes the data frame. Then df.describe, which gives us the summary statistics of the data frame. Then df.sort_index, which sorts the data frame based on the index, and also df.sort_values, which is used to sort the data frame based on the values of a particular column. So with this, we have completed the topics for this session, and thank you so much for joining me in today's session. I appreciate each and every one of you for being part of this course, and stay tuned for more exciting content in our next video. Until then, take care and see you in the next session.